Hi guys, I'm Raymond.
I'm Jade.
And I'm Hannah, and today we'll be focusing on the topic of decimals. Oswald states that fractions and decimal work begins in level 1, so recognising and describing 1/2 as one of two equal parts of a whole. Level 2, recognise and interpret common uses of halves, quarters, and eighths of a shape and collections. Level 3, model and represent unit fractions, including a half, a quarter, a third, a fifth, and their multiples to a complete whole. Level 4, investigate equivalent fractions used in contexts. Level 5, recognise that place value systems can be extended beyond hundredths. Compare, order and represent decimals. Level 6, add and subtract decimals with and without digital technologies and use estimation and rounding to check the reasonableness of answers. And level 7, round decimals to a specified number of decimal places and connect fractions, decimals and percentages and carry out simple conversions.
And in this presentation, we'll be focusing on level 5, which centers on place value. Students need to recognize that the place value can be extended beyond hundreds, thousands and millions, and be able to compare, order and represent decimals. Before getting into decimals, it is essential that students have prior knowledge of basic fractions, the appropriate mathematical language, such as place value, digits, and decimal points, and a proper understanding of place value, so knowing the tens, hundreds, and thousands.
It is important that the students learn decimals because it relates to a lot of real life situations, and since we don't count everything in whole numbers or discrete quantities, in some cases we need to break down the whole number to be more precise, such as height, money, or any continuous measure. The objectives are for the students to explore decimals, place value, and read and write decimals using tenths, hundredths, and thousands, and to be able to compare using greater than and less than notations.
Before we get started with the lesson, we would give a bit of an introduction to decimals, so why they are important and when we would use them in real life situations.
Actually, decimals appear all around us on a daily basis. A day hardly goes by that skips encountering decimal notation. For example, anywhere that involves the distribution or counting of money, like purchasing breakfast or lunch, filling a vehicle with petrol, or shopping. In order for students to understand and make a link to real life situations, these posters will be given out to demonstrate why decimals are used.
Okay. But before they could really understand the significance of these posters, they first need to have a strong understanding of place value.
Students will be introduced to the decimal place value after they have an understanding on fractions. And because of this understanding, we can use fractions to introduce the decimal place values. For example, you would have on display a 10 by 10 grid, then ask the students how many boxes make up the grid. Once the students agree that the grid is made up of 100, you would get a volunteer, which I have Raymond, to come up and count a row of 10 or a column, which is 10 squares, and shade it. Then ask your students what the shaded part represents, and they would answer 1/10 of a whole. This is where you would ask the students to explain, or you could explain to the students, ways in which we could write this as a decimal. It could be written as 1/10, as a decimal, 0.01, or as a fraction, 1 and 1/10. The 0 is before the decimal to demonstrate that the number is not yet a whole. The first place to the right of the decimal is the tenths place. Now this can be a misconception when they are first learning, as ones usually comes before tenths. So before you go on to this, you must make sure that that is established. And then once that is done, have the students come up and shade in only one square of the grid. Ready? Then ask the students, what is this shaded part represented? It is 1/100th, which is written as 0.01 or 1/100th. Notice there is now a 0 after the decimal and then the 1. This is because 2 places right of the decimal is the hundredth place. After this, ask the students, is 0.1 greater than or less than 0.01? The students being new to this concept might have the misconception that the one with the more numbers is greater than the one with the lesser numbers. Also, they have been taught that hundreds are bigger than tens, so be sure to provide a visual demonstration for them to compare which one is closer to the decimal. Another misconception you might come across is that 0.01 and 0.10 have different values because there is an extra number.
For an extension of place values, students can then move on to comparing decimal numbers. The prior knowledge we would expect from the students is a strong understanding of place value with decimals. Without this knowledge, the students would find comparing them extremely challenging. When comparing decimals, we first look at the whole numbers. If these whole numbers are not the same, we don't have to look at the rest of the decimal number. For example, if we had the numbers 54 and 274 thousandths, and the number 40 and 933 thousandths, and were asked to compare them, we would try to find out which number is the larger one and which number is the smaller. Our first step would be to disregard everything right of the decimal place and focus on the whole number. We know that 54 is bigger than 40, so therefore it is the bigger decimal number. We would write this as 54 and 274 thousandths is greater than 40 and 933 thousandths. However, when the whole number is the same, that's when we look to the rest of the number. So if we had the decimal numbers 36 and 274 thousandths, and the number 36 and 618 thousandths, these whole numbers are the same. So we then look to the number in the tenths place first. These two numbers are not the same, so the larger number in the tenths column is the larger decimal number. In the tenths column, we have the 2 and the 6. So we would write this as 36 and 618 is greater than 36 and 274. Most students will be fine with the comparing of the whole numbers, but run into trouble when the whole numbers is the same. Students tend to think that the longer the number is, the larger the number is, the longer it is. This thinking, however, only works with whole numbers. Another misconception students may have is the opposite of what I just said. So some students will then say that the shorter number is the larger one, which is also incorrect thinking. A good activity to get students learning and feeling comfortable with comparing decimals is the decimal numbers between. This is an open-ended task that has many correct answers. For this, you ask students to write down 15 numbers between 3.1 and 3.4, or you can choose any two numbers that you desire. Some students will tell you that there are only two numbers between there are only two numbers between, so they would say 3.2 and 3.3. This shows you that they are not thinking past tenths. Getting students to make a number line will help assist them so they have a visual representation. So you would draw maybe a number line. You draw a number line on the board and fill in the information that we do know. So we want numbers between 3.1 and 3.4. Next, we would fill in the numbers that they have told us. So we're assuming they would have told us 3.2 and 3.3. But then we also need to explain that this can be, again, divided into many parts. So here would be 3.15 and 3.25, 3.35, and so on. It can just be kept being broken down. Another activity is less than, more than, which is also an open-ended task. You can do it as a class or individually, it doesn't really matter. It just depends on what level your students are at and what you're hoping to achieve with this lesson. If you were doing it as a whole class, you would write on the board something a bit like this. So only using the one number with a whole lot of spaces. You would get your students to come up with numbers to fill in the gaps that would make the statement true. And in this activity, there are multiple numbers that you could use.
We hope that our video presentation on decimals and place value was insightful and provided you with ideas for classroom activities.